And welcome to Otten Math. In this edition of Otten Math, we're going to talk about the quadratic formula and the discriminant. All right, we've talked about different types of quadratics, different forms of quadratics: standard form, intercept form, and vertex form. And we've talked about factoring the quadratic, and we've talked about finding the roots or solving for x or finding the zeros. So let's take an example here. I have x squared plus 4x plus 4, and I want to find the factors of this quadratic. So the factors of this quadratic end up, if you use a diamond and box process, or if you recognize that this is a perfect square trinomial, ends up being x plus 2 times x plus 2. Now I can also ask you to solve for x, and I create an equation where the quadratic is equal to 0. In this case, either x plus 2 is equal to 0 or x plus 2 is going to be equal to 0. So my zeros, or I say the roots, or I say the solution for x is going to be that value of x that makes this entire value equal to 0. So in that case, x is going to be -2 and -2. So I say I have one real solution in this case. My zeros are -2, my roots are -2. So I can say find the zeros, find the roots, or solve for x in this equation, this quadratic. And you're going to end up giving me the value of x is equal to -2. Now graphically speaking, all we're doing is we're finding the value where the parabola crosses the x-axis. In this case, it only crosses the x-axis, or touches it at x is equal to -2. So if I were to draw my parabola, I would start with the vertex here. And it's not always the case that the vertex is going to be the x-intercept. It's only the case where I have one real solution, as in this case, or a perfect square trinomial. Okay, so let's talk further about the quadratic formula. When I ask you to solve for x, in this case, it might be difficult for you to use the diamond and box process to solve, in which case you can use the quadratic formula to solve, to find the roots, or to find the zeros of the quadratic. And the quadratic formula is simply minus b plus or minus the square root of b squared minus 4ac all over 2a, as you write the quadratic in standard form. All right, let's talk about what the discriminant is. The discriminant is the value underneath the radical. So I'm going to move on to another slide and talk about the discriminant first and then come back. So discriminant is a term used to express the value of the quadratic formula under the radical. The discriminant is equal to b squared minus 4ac, and it's not equal to the square root of b squared minus 4ac. So if I ask you to find the discriminant b squared minus 4ac, it's a portion of the quadratic formula. Now the discriminant will tell us a lot of things. If the discriminant is positive, then there are two real solutions, right? So if I have a positive value underneath the radical, I'll end up with two values for my roots or solutions. It'll be minus b plus or minus that positive value, that's the discriminant, all over 2a. If the discriminant is 0, I'm going to end up with just one solution, right? Minus b plus or minus 0, I end up with my solution as being minus b over 2a. That's one real solution. If the discriminant is negative, then I have two imaginary solutions. So let's talk about what that looks like graphically. Okay, if the discriminant b squared minus 4ac is greater than 0, I'm going to end up with two real solutions. And what that means is the parabola crosses the x-axis in two locations. It can be a happy parabola here, right? Or it can be a sad parabola. But in both cases, it'll cross the x-axis in two locations. Where b squared minus 4ac is equal to 0, I just have one real solution. That one real solution is the vertex of the parabola. It touches the parabola, it touches the x-axis in just one spot. And where the parabola does not touch the x-axis at all, I actually have no real solutions. And in that case, b squared minus 4ac is going to be less than 0. Now it can be above the x-axis, right? Or it can be unhappy face below the x-axis. In either case, the graph does not touch the x-axis. I have no real solutions, And in fact, I have two imaginary solutions. All right, so let's recap. We've got factors of a quadratic. It'll just be x plus 2 times x plus 2. Now, if I wanted to solve the quadratic and set the quadratic equal to 0, my solutions, zeros, or roots would be, in this case, -2. And I would write x is equal to -2. And that's just the point where the parabola crosses the x-axis. Sometimes it's going to be difficult for you to find or to factor a quadratic. So you can use the quadratic formula based off of the quadratic in standard form, where the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, if I have one solution, that means the discriminant is 0. If I have two solutions, two real solutions, the discriminant is going to be positive. And if I have two imaginary solutions, the discriminant is going to be negative. Graphically, two real solutions, I have the graph crossing the x-axis twice. One real solution, graph crosses the x-axis once. And no real solutions, the graph does not cross the x-axis.